Hello guys, so this would be my first um, video with respect to C++. So I have a playlist that I started for C and I will continue to make videos, but I'll start here by explaining an array of pointers to integers with the C code that I would have run a while back. I'll try to explain the code here now. Now, when we talk about in this code here, you see we have int asterisk array 4 r4. So this is pretty much an array of pointers, right? So what I'm having here, right, arr of 4, how you interpret this code is that this is in parentheses, so it takes precedence over this asterisk here. So this part here you have to look at first. So it's pretty much a simple array, right? So arr of 0, um, 1, 2, and 3. All right. Now, so this is telling you that this array, the what it stores are pointers, right? So this is a pointer, this is a pointer, it's storing the pointer, right? And what is a pointer? It's basically an address to what? To integer here. So there are 4 pointers here. So it's an array of pointers. So they're pointing to integers. So it seems I have int a, b, c, and d. So I have 4 integers, right? So this is like A, B, C, and D. Now, this here would have an address of ampersand A, ampersand B, ampersand C, ampersand D. So let's say this is ARR of 0. This would contain ampersand A. This would have ampersand B, ampersand C, ampersand D. Right? So the pointer is pointing to, or it stores the address of this integer here, right? A. So in this case, this here is inside here, and the pointer is pointing to this point here, right? But what are the contents of A, B, C, and D? So the contents of A, B, C, and D, we have 10, 20, 30, and 40. Now, when you look at the code, you'll see a couple of things here, right? I have used terms like ARR of I, or you can say ARR of 0, ARR of 1, ARR of 2, ARR of 3. Now, what are these? Now, because of the fact that I define here that this is an array of pointers, right, to integers. So ARR of 0 contain is really should be equal to what is stored inside here. So it contains ampersand A, this is ampersand B, ampersand C, ampersand D, right? Now the other thing I have in the code would be this here. Ampersand, let me see. Oh, I need to move this so you can actually see that. So I have, yeah, here. I have something like ampersand ARR of I. Now, this here is ARR of 0. What is inside here? So the address of this pointer gonna be ampersand ARR of 0, right? So ampersand ARR of 0 is the address of the pointer, but ARR of 0 is the address of the integer that is stored in the pointer. So the pointer is pointing to, int A, right? So there's a differentiation here between, ARR of 0 and address of ARR of 0, right? What I want to say is that ampersand A is the same as ARR of 0 because the pointer, the value of this, in this array of pointers here is ampersand A. If you dereference ARR of 0, because ARR of 0 contains the address of A, so what I'm saying now, if you have something like asterisk ARR of 0, what this means? It means that because this here is equivalent to ampersand A, so the dereference operator gonna give you what is the value at A. So it should give you 10. So ARR of 0 dereference here will give you this. ARR of 1 dereference will give you 20. Now, and so on. Now let us look at the actual output of the code. So I will zoom this code so you can have an idea what I was doing here. It's pretty much standard C++, just formatting stuff here, putting a space and writing some, just getting it in a printable format. I'll go slow so you can try to rerun this yourself. So what I'm doing here, I have a for loop and I'm iterating over the array. So I'm taking, this is gonna be 0, 1, 2, and 3, and I'm finding what value is stored at ARR of 0 dereference. So I'll have 10, 20, 30, 40, and the address at index ARR of I. So this should be the address, the value contained at ARR of I. All right. And this here is the, well, pretty much this is an address, but what is this address? It's ampersand A. And address at index ampersand ARR of I would be the pointer's address. All right. So let us just look at the code, the output of this here. May I bring this in here? So I have value at index 0. So let's try to map everything out now. I'm here and can I get this up? Yeah. Let's see how we're gonna. Value at index 0 is 10. So value of index 0 here, because this is dereferencing ARR of I, right? When we look at this here, I've explained that ARR of 0 dereference, ARR of 0 is the same as the address of A, but we dereference it so we get what is in A. All right? So you can look through this now. You should have an idea what I'm trying to do here, or what I did here, right? You can run this code and you should be able to learn something. So the gist of it is the array of pointers to integers. The address of each pointer is ampersand ARR of I, and the address contained within the pointer, that is what is stored in the pointer, is the address of the integer. In this format, integer is ampersand A, right? And it's equal to ARR of I. So this here is stored inside the pointer, and when you dereference, where I did that. Well, I didn't show it here, but I show it here. When you dereference ARR of I, you get the value at A, B, C, and D. Alright, so I will stop here for this video, and if you have any questions, you can message me on this. I'll try my best to explain. This is one way of, getting better with your coding, trying to explain stuff, right? You look at the code, you run it, and then you try to understand what is really happening. Good, so I'll stop here.